window. Okay, so what we're going to do now is let's add a transform to this. Let's add a simple transform, which will take the data from here and do something with it. So to add a transform, the transform is the green box up here. As you can see, if I hover over it, it says transform. Just click on that and then drop it into the screen. Now what I want to do is I also want to add a dependency between this transform and between this source component. And the way I do that is I go to the dependency button, which is this icon here, click on it. And then if I click once on the two components, it will draw a line. So this line now references a dependency. So let's go back into this. So I said I wanted to create a simple transform. So I've got the transform, and as with the source, it's populated the playbook component. It defaults, as I said previously, to new component. So let's give it a name, and let's call it, it's a trans. So we're going to call it a trans initially. Let's do a group by, and we can group it on sensor data. Okay. Right. Now we have to select a playbook subtype. So if you remember, subtypes describe the type of component that you want to generate. Now for a transform, there are two types, internal and external. Internal is where you will be allowed to write SQL, which can interact with any of the objects that it's connected to, or any of the objects which have been created within this data pipeline. External is a special one. So an external one is where it will provide you with a default Python script, which will automatically allow you to interact with, again, any of the components which have been created within this data pipeline, but will also allow you to write any Python that you need to. So for example, you can actually create an external transform to be a source which connects to an API. So if I wanted to connect to Salesforce, for example, I could write an external transform which would then connect to the Salesforce API and read that data in, and I could then use that as a source. We'll go into external external transforms in another session. But for this particular session, we're just going to be using an internal transform, which is a SQL transform. So if I click on that, and as happened with the source, once you click on the subtype, the component details are automatically populated and describe or show the key value pairs that need to be captured in order for that transform to be executed by IOblend engine. So now we have selected playbook subtype. It's populated the playbook component details. So let's go through some of the important features that we need to, or the key value pairs that we need to add in order for this simple transform to execute. So the first one is run once only. So we've described the situation of how epochs work. So when the IOblend engine executes a pipeline, it will execute each of the components in sequence of the run order. When it gets to the last one, it'll then go back to the beginning and re-execute them. So that works really well when we're doing streaming. What we can do with transforms, which is slightly special, is we can say, actually, I only want you to run once. So irrespective of the number of epochs or iterations that your data pipeline has gone through in its execution by IOblend engine, this will only be executed once. So if I did have another component after this, it would skip transgroup sensor if I set the run once only to true and go into the next component. In this instance, I want it to continually run every time my data pipeline runs. So I'll leave it at false. Data pipeline name. So as with the source, we described that the data which is being read in from S3 is automatically populated or populates an internal memory table, a data frame, which is continually refreshed, it's continually added to with the new data which is being read from each iteration of the data pipeline. Likewise, with the transform, any data which has been generated by the SQL will be stored in a new internal table, which is going to be generated as an output from this transform. So let's call it trans group sensor table. Basically, as good practice, I tend to use the playbook name for the component and then postfix it with table. Next is this actual select statement that I want to execute. Either you can write it in here and scroll across, or it's actually easy. If you double click on this, it'll open up an editor window where you can then type in your SQL. Just paste it into there. readable. Okay, so it's quite straightforward SQL. All I'm doing is I'm selecting the device ID, the temp, the heart rate, and the created date from source S3 static sensor 01, and we can just confirm that they are the columns. So as you can see here are the columns which have been generated for that internal table: device ID, temp, heart rate, and created date. That's what I'm using. So let's go back to that window. Okay, and then all I'm doing is I'm creating an average for each heart rate partitioned by the device ID. Okay, so we've created our SQL again, which is just going to be pulling the device ID, temp, heart rate, created date, and then it's going to be doing a group by using partition over the device ID and create an average of the heart rate. So fairly straightforward. So let's select that. So I've entered it. So if I close it, it'll be saved automatically into my window. So if I go back to IOblend Designer, and you can see it there. So there it is, it's fine. Okay. But the next set of key value pairs are process. So as with most SQL, this SQL will be executed on the entire result set from source _ S3 _ static _ sensor. One of the things that we can do as well is we can ask it to execute on this SQL to execute on every single record, individual record, which has been generated by this. And you'll do this from a data quality point of view. So for example, if I wanted to check the data quality of this record against completeness and consistency, I could say, let's check device ID and make sure device ID is a number. So the SQL could check to make sure that the device ID is indeed a number. I could then ask it to execute that against every single record. And what it will do is it will then generate a success table and an error table. And all records which meet that criteria will be written to the success table. And all records which fail that criteria will be written to the error table. So that allows us to very neatly build in data quality into our data pipeline using this feature. And obviously anything which has been generated within the error table can then be processed outside of this data pipeline, and anything which has been successful from a data quality point of view can then be can actually flow on within that data pipeline and be processed. Conversely, what you could also do if you wanted, if any error has been generated, you can halt all of the data pipeline. But the key aspect here is that a transform gives us the ability to execute a transform not only against the entire table, but against each individual records, which allows us to do data quality on the fly. In this instance, we're not going to do that. We're just going to execute the transform in its entirety against all of the data which has been read from its source or its dependency. Dependency. So first of all, the dependency. So as you can see here, dependency is pointing to a table that it's reading data from. Because I've got this dependency which I created earlier on, it automatically populates its dependency, identifies that its parent is this, and pre-populates it. You can have more than one dependency. So for example, I could have several sources and I could have a transform which is reading data from all of these sources. So therefore I'd have dependencies to each one of those sources. And what I can do in those instances, I can say actually only run if all of my sources that I'm reading data from have updated new data or have updated new data recently, or I can set it to false, which means if at least one of them has loaded new data, then execute it. So this gives us the ability to do an and or condition on the dependencies. And lastly, as previously explained, is the debug option. So what do I want to see on the designer output window when this is running? So in this instance, I've set display table to true, the limit is to 5, show me the schema. Let's set pause to true. Okay, and show stats. Okay, so now I've made those changes. What I need to do is, as described previously, although those changes are present within this session, they've not been saved to the data pipeline configuration files within the data pipeline project. So to actually save those and to make sure they're permanent, I go to data pipeline and save, and it comes up with the save dialog box, which basically confirms where I'm saving it to and the state directory and the name. They're pre-populated because I've already generated this. So I'll just click on yes, and then it saved it, and then it refreshes the whole screen. If I click on it, we can see that our values have been pre-populated and still there. Okay, so in the meantime, we've still got the IOblend engine run screen running in the background. So now I've added this transform, I should be able to go back into that window, and now I can say continue. So now that I've made the changes that I wanted to my data pipeline project, if I now click on yes to continue, it should pull those up. So it's now going through the next iteration. So it reads the data. So it's read the data and it's now saying, do you want to continue? So yes, I want you to continue. Error when transform, check transform error is table view not found. Okay, so as you can see, what did I do? I copied my transform, my SQL transform into my transform, and actually had the wrong table name. So it's actually come up with an error here telling me this. So it's saying, well, I've just tried to execute your transform, and actually the table view is not found. So this table name does not exist, which is true. I've not created that table. So if I go back into that to check it, so that's my table name. That's what it should be. So let's copy that. Let's go back into the SQL. And as you can see, it's got the wrong table name in there. So let's put the right table name in there. Okay. Close it, so it saves it. Now, once again, I have to save my data pipeline because I made changes to it. So let's click on save. Okay, I can go back into my run window. I've made those changes. I do want to continue. Now I want to reset because I've made changes to my data pipeline. So let's hit reset. Okay, and now it's asking me, now you reset and you're on the next iteration. What do you want to do? Well, now I want to continue. And now it's just confirming you've already hit reset. So do you want to continue? So yep, I know I've hit reset and I do want to continue. So let's click yes. Okay, so now it's going off, it's reading the data. It's read the data, it's asking me because I asked it to pause, do I want to continue? So obviously if I set pause display table to false, then I wouldn't get this yes no message, but it's true, so that's why I'm getting it. So let's click on yes. Okay, and that's done the transform. So now you can see output from transformation, and it gives you the transform name, which was transport group, for table, and it tells you the table, which has been the internal table which has been generated. And here is the output from it. So we've asked it to pull back device, temp, heart rate, create a date, and then generate average heart rate, which is done. It's now also added data lineage information to each individual record which has been generated. So it tells you the process time, when the IOblend created date, and also which data pipeline generated it. So now we have data lineage of which process and when this record was generated. Likewise, we also have the same data lineage being added to this source as well. And it does that by created date, and then it also adds the name of the file that it's read. So each record is being pulled by this file. So every single record will have tagged to it the file that record has been generated from or pulled from the source, giving us record level data lineage. So to confirm, we have full data lineage. We have data lineage at the process level, which is the actual designer graph that you can see through the components we are generating on the screen. And we also have record level lineage, as you can see here. Okay, so that's pretty much it. I could continue and go through the cycle again, but in this instance, I'll probably just stop it. And in the next video, we'll progress to proceed to write this out to an actual sync.